7.2 Similar Polygons. You will have a book assignment today, and then next week we have worksheets all week with a quiz on Friday. We have a what? Quiz on Friday next week. Okay, there we go. Similar polygons. Hey, focus here. Back in elementary school, you would have defined similar polygons as having the same shape but different size. So on the very top blank it says similar figures have the same shape, but they would be different sizes. So like if you had a picture of a big square and a little square, you'd say they're similar. If you had a picture of a big square and a big rectangle, they'd not be similar because they're not the same shape, right? But we're not in elementary school anymore, so we're going to put a little bit more detail to our definition. Polygons are similar if their vertices can be paired so that corresponding angles are congruent and corresponding sides are in proportion. So, I mean, they're still going to have the same shape and be different sizes, but now we have to check if the corresponding angles are congruent and if the corresponding sides are in proportion. What I mean by in proportion, they have to have the same ratio across the board. And corresponding sides, if I had two triangles, corresponding sides would be like the shortest side of one triangle to the shortest side of the other triangle. And then the longest side of the first triangle would correspond with the longest side of the second triangle, and then the guys in the middle. Okay, corresponding doesn't necessarily mean bottom to bottom, left side to left side. You have to make sure you get the sizes in there, that you go short to short and long to long. Okay. The similarity ratio, that next blank there, is the ratio of corresponding sides. A similarity ratio is the ratio of corresponding sides. Since in math we've been writing our ratios as fractions, your similarity ratio should always be written as a fraction in lowest terms. And I will also refer to a similarity ratio as a scale factor, so make sure you put that there as well. Scale factor and similarity ratio mean the same thing. So today you're going to have to find your scale factor among similar polygons. So you just find the ratio of corresponding sides. Did you see up on the top where it says similar figures have, and then in parentheses there's this little guy? That's your similar symbol. That means similar. Alright. Example 1 then. Triangle ABC is similar to triangle XYZ. This is called a similarity statement, kind of like the congruency statements back from chapter 4. They work the same way. They tell you which angles line up, they tell you which sides go together. Don't be dependent on the pictures, because they will flip and turn and twist the pictures. So make sure you always double check with your similarity statement, because that thing will always be true. If you notice, I didn't even label my triangles because you don't really need the pictures to answer these 4 questions. According to the similarity statement, angle B should be equal to which angle? Y. Angles will be equal. Sides will be proportional, so they're setting up a proportion with corresponding sides here. BC is to YZ as something is to XZ. AC. Part C, the measure of angle A would have to equal the measure of angle X. And then D, the other proportion. BC is to YZ as what is to XY? AB. Good. Proportions, you guys, a lot of times are just So similarity statements will always be true. Don't get hung up on the pictures because I will try and throw you off with the pictures. So make sure you use your similarity statement. Number 2, determine whether the parallelograms are similar, and then we're supposed to explain. They have to be the same shape, different sizes. Well, they're obviously both parallelograms, so we're good there. But now we have to check if angles are congruent and sides are proportional. So what do you think here? Yeah, what? The sides are proportional. To check that, you'd find the smallest side of one parallelogram, 1, and line it up with the smallest side of the other parallelogram, 2, and then write the ratio. What's 1 over 2? 1 over 2, right? 1/2. Then you take the longest side of the parallelogram and write that to the longest side of the other parallelogram. 2 over 4 would give me 1/2, right? Okay, so my sides are proportional. So we've met that second condition from above. Now we have to make sure all the corresponding angles are congruent. Well, what do you remember about your quad tree and the angles of parallelograms? Opposite angles are, okay, so then angle D would be 120, and angle M would be 100. What about the consecutive angles? They have to be supplementary, right? Same side interior, so J is going to be 80, which means L is, and over my other parallelogram, C would be, which means A is 60. So do I even have any angles that are congruent among the 2 parallelograms?
No.
So are these parallelograms similar? No. Determine if the parallelograms are similar. Not similar, explain. Corresponding angles are not congruent. That slash through the congruent symbol means not. So you have to meet both things. You have to have proportional sides and congruent angles. You'll do this a lot on your assignment today. Make sure you go short to short, long to long when you're checking your sides. Another handful of your questions will be like number 3. Triangle ABC is similar to YXZ. We need to find the value of little x and the length of AB. So my little x here, is that representing a side length or an angle measure? Side. And if these triangles are similar, then their sides are congruent or proportional? Proportional. So then I'm going to have to set up a proportion. I like to start with my unknown. X, which is the length of AC, would correspond with the length of YZ, which is what? 50. So X is 250. As, now I need to go back to that first triangle. They only have one side length there. As 12 is to, yeah, because BC would correspond with XZ. Don't depend on your calculators. 12 and 40, can I reduce that? By what? 4. How many times does 4 go into 12? And into 40. Okay, so now when I go to cross multiply, 10 times x, 50 times 3, divided by 10 means x is 15. You should get the same thing if you want to use 12 and 40 in a calculator, but don't depend on them. You don't need to. We also have to find the length of AB. I called it Y. Maybe you want to do that too on your picture. It's representing a side, so I have to set up another proportion. Y in triangle ABC corresponds with what? 30. As, now I gotta come back to that first triangle. What do you want to use? You can use 12 and 40 again, or you could use 15 and 50. It wouldn't matter. I'm just going to use 12 and 40 because I know those ones are there. Again, if I reduce 12 over 40, we know that's 3 over 10. Cross multiply, 10y would equal what? 90. Divide by 10, and my y value is 9. Do you have to simplify first? Absolutely not. That makes smaller numbers. Questions on 3? Okay, go ahead and try number 4. You have similar trapezoids. You have to find the measure of 2 angles and the value of x. I want the actual degree measure of the angle, not just which one it's supposed to be equal to. Use your similarity statement to line up your congruent angles.
I don't know how to find angles.
If I look at my similarity statement, angle H is the 3rd letter, so it needs to correspond with the 3rd letter. So angle H is going to be congruent to angle L, which means the measure of angle H is 74 degrees. X is a side length, so I'm going to have to set up a proportion here. X on this 2nd trapezoid corresponds with which side on the other trapezoid? 35. As, now I have to come back to that first trapezoid I used. 42 is to 30. Try not to be dependent here on your calculator. 42 and 30, what goes into both of them? 6. So this would become 7 over
5.
Okay. 5 times x would be 5x, right? You still don't need your calculator. This would be 35 times 7, you agree? And then I would have to divide by 5, wouldn't I? Well, 5 divided by 5, that would just give me that x. What's 35 divided by 5? 7. What's 7 times 7? 49. Isn't that what you get if you would have taken 35 times 7 and divided by 5 then? Okay, so you don't have to be dependent on your calculator. Nice, huh? Cross. Your alarm's going off. Angle D. Oh, geez. Congruent to angle B. But I don't know angle B. Opposite angles are congruent. 74, right?
Yeah.
No.
Wait, hold up. This guy's even marked. Good try though.
Trapezoids. If this thing's a trapezoid, what do I know about those yellow lines? They're parallel, right? That's the definition of trapezoid. So then this green segment would be called my transversal. So angle B and angle P would be classified as, which means they're supposed to be
180.
So then 180 minus 81, and then that means that angle D has to be 99. Does that make sense?
Yeah.
Cool. Totally. Okay, flip it over.
Course is a word problem.
Good job.
It's apple.
Oh. Alright, number 5. A rectangle with a perimeter of 20 has a side length of 4 centimeters. If the right side's 4, what's the left side?
4.
Good. And how would you find the perimeter of any polygon? Add all the sides up. So what's 4 plus 4? 8. So 20 take away 8 leaves 12 divided by 2, because the top and bottom are equal. 6 and 6. Second perimeter, or second rectangle, has a perimeter of 40 and a side length of 8. So if I choose the left side to be 8, then the right side has to be 8. 8 plus 8, 16. 40 minus 16 is divided by 2. Alright. Determine if they are similar. Okay, well they're both rectangles, so we're on a good start.
Yeah.
Are the angles congruent? Yep, they're all 90. So now we have to check if corresponding sides are proportional. That means like short to short, long to long. So what's the shortest side of my top triangle?
4.
And that would correspond with,
8.
in the ratio 4 to 8 reduces to, okay, longest side of the top triangle. Corresponds with,
12.
the ratio 6 to 12 reduces to, okay. Do I need to check the other two sides? No. So are these rectangles similar? Yes, they have congruent corresponding angles and their sides are proportional. If they are similar, give the similarity ratio. What's the ratio of the top triangle to the bottom triangle? 1 to 2, 1/2. This is your similarity ratio. Also known as a scale factor. What's the ratio of the top perimeter to the bottom perimeter? 1/2, right? That's true for every set of similar polygons. The similarity ratio will always be the same as the ratio of the perimeters. Okay. It wouldn't matter if it's pentagons or octagons or whatever. The ratio of two sides will always be the same as the ratio of the perimeters for those figures. Fish? Alright. Number 6. Sketch triangle XYZ and triangle MNP so that angle X is congruent to angle M, angle Y is congruent to angle N, and angle Z is congruent to angle P. They don't have to be perfect, just draw little triangles. And then make sure that you mark your angles congruent. And then your second sentence gives you all their side lengths, so take those and label your triangles. They want us to determine if these triangles are similar or not. You'll have a good amount of questions like this today on your assignment. The pictures will already be drawn for you. But then you have to do two things. You have to, 1, check if the corresponding angles are congruent, and then 2, check if corresponding sides are proportional. The angles are always the easiest to check. Are all 3 angles of XYZ congruent to an angle in triangle MNP? Okay, so I know I've got the congruent angles. Now I need to check if the sides are proportional, making sure I do corresponding sides. So short to short. What's the shortest side of XYZ? 12. Shortest side of MNP? 18. Reduce by 6, and that would give me then go to the longest side. What's the longest side of XYZ? 16, which would correspond with 24. Reduce these two by 8 would work, and that would give me 2/3. And then check the remaining sides. 14 to 21, reduce by
7.
and that would make it 2/3. Make sure you check all the sides. If the first two are in the same ratio, but the third one is not, then they're not similar. So make sure you check them all. So can we decide if these triangles are similar? Yeah, because our angles are congruent, our sides are proportional. The book's going to say this. Then give the similarity statement. Triangle XYZ is similar to, and it works the same way as chapter 4, line up the congruent angles. X goes with M. Y goes with N, and Z went with T. Good. What would be my scale factor to these two triangles? 2 to 3. It's whatever that ratio is that you keep getting when you simplify. That's your similarity ratio, your scale factor. Yes. Because they may not be in ratio.
Yeah.
You have to check them all. If the first two are not, then you don't need to check the rest of them.
Yeah.
But if the first two are, then you want to check your third one. Or if it's a four-sided figure, just make sure if they continue to be the same, then make sure you check them all. Does that make sense? Okay. Questions? Okay, similar polygons. They have to have congruent angles. Sides have to be proportional. Fish? Alright, we're going to leave the other 5 or so for Tuesday.
Done.
So here's your assignment for the weekend.
I knew it. Why are you giving us an assignment over the weekend? That's what I want to know.